The more I study the universe's singularity, the more confused I become, to the point of suspicion. Perhaps the universe was never truly born at all. What we've always called the Big Bang might not have been the beginning, but merely a stopover in a cosmic cycle. If that's true, it means the very foundation of cosmic physics, which we've painstakingly studied for decades, could crumble in an instant. It's a disconcerting feeling, like discovering the ground beneath your feet has been hovering over nothing all along. Even so, I have to confront the latest discoveries, like the undeniable temperature spots in the cosmic microwave background and the most distant starlight captured by the James Webb Space Telescope. They are all reminders that the seemingly complete story in our textbooks is actually full of holes. So now I want to step into this almost unsolvable puzzle with you and face the question that has troubled humanity for millennia. What was hidden before the Big Bang? Before we begin, let me ask you a question. If we could truly see the infancy of the universe, what would it look like? You might imagine it was a pitch-black void. After all, there were no stars, no galaxies, and even light itself couldn't travel far. But the universe left its own baby picture behind, hidden in every corner of the sky. Though it's too faint to be detected by our eyes, if we look for it, we find it's everywhere. Scientists call it the cosmic microwave background, or CMB. Since it's the very first light left over from the Big Bang, it has become our only window into the universe's childhood. This light appeared 380,000 years after the Big Bang. Before that, the universe was so hot and dense that any photon that appeared would be instantly scattered by an electron, unable to travel. The entire cosmos was like a roiling fog, and nothing could be seen clearly. It wasn't until the universe cooled enough that electrons could finally combine with atomic nuclei to form the first true atoms. In that moment, for the first time, photons broke free and traveled unimpeded. The cosmic fog was lifted, and a flash of light filled all of space. We can still receive this light today, but after 13.8 billion years of cosmic expansion, it has been stretched into the form of microwaves, far too faint for the naked eye. But it is this light that has become our most reliable evidence of the early universe. It recorded not just light, but the very image of the cosmos as it was just beginning to take shape. Yet this baby picture is not a perfect curtain of light. On the contrary, it's covered in nearly invisible temperature spots. Don't underestimate these spots. Their temperature differences are only 1 part in 100,000. But it was these tiny irregularities that gave the future universe a story to tell. Areas where matter was slightly denser would later collapse to form galaxies. Areas that were sparser became the great cosmic voids. In other words, the star fields and galaxy clusters we see today were already written into that photograph. So the CMB isn't just light, it's a blueprint that determined the ultimate fate of the universe. Even stranger, some of these spots have bizarrely abnormal temperatures, like the so-called cold spot, which has led some scientists to suspect it might not be a signal from our Big Bang, but a remnant, a bruise, from a previous universe. But before the mystery of the cold spot could be solved, the universe was already brewing new changes. The first stars were about to ignite in the darkness. But don't think that just because photons were free, the universe was suddenly filled with light. In fact, for a long time afterward, the universe remained boundlessly dark. Why? Because there was nothing to produce light. The entire cosmos was terrifyingly quiet, like a bottomless well. Imagine a universe filled only with hydrogen and helium, so uniform it's suffocating. No stars, no galaxies, no sense of direction. Just isolated primordial matter. Scientists call this period the Cosmic Dark Ages. But this darkness wasn't the end. In the void, gravity had already begun its work. Like an unseen hand, it slowly gathered the hydrogen and helium together, waiting to ignite the first flame. When the density and temperature grew high enough to finally cross a critical threshold, the first stars ignited with a roar. They are known as population 3 stars. Unlike the stars we are familiar with, they were astonishingly large, some hundreds of times more massive than our Sun. But their lives were incredibly short, lasting only a few million years. Yet, it was they who first tore through the darkness. Their light gave the universe direction for the first time, and their fusion created carbon, nitrogen, and oxygen, the essential elements for life. Without them, there would be no galaxies, no planets, and certainly no us. Even more stunning, their deaths were just as spectacular. After their brief lives, they exploded as supernovae, scattering these newly forged elements across the cosmos. In that moment, the stage of the universe was finally set with true light and heat. But the question is, how could we possibly see these stars that burned out long ago? The answer is the James Webb Space Telescope. Launched in 2021, it was specifically designed to capture the faint starlight that has been stretched by cosmic expansion into the infrared spectrum. This light has traveled through the vacuum for over 13 billion years and is completely invisible to our eyes. Only Webb's infrared vision could find it again. And the results shocked the entire scientific community. In just a few short years, Webb has photographed galaxies that are far earlier and brighter than we ever expected. 1. With the designation JWST 14-0, pushed the record to the absolute limit. Its light comes from just 280 million years after the Big Bang. At that time, the universe was less than 2% of its current age, yet it had already produced such massive galaxies. Even more incredibly, these galaxies were not isolated, they were shockingly numerous. This forced scientists to ask a new question. How did structures we thought took billions of years to form complete themselves in just a few hundred million? Was our entire script for the universe wrong from the very beginning? Logically, the journey from a primordial cloud of gas to a massive galaxy should take an immense amount of time. But the images from Webb tell us that galaxies appeared within a few hundred million years and were far brighter than theory predicted. This has led scientists to suspect that our models of galaxy formation might be fundamentally incomplete. If that's the case, it means the cosmic timeline we've constructed over decades may need to be rewritten. The evolutionary process we thought was slow and gradual might have happened much faster in the early universe. The problem is, we still can't find a reasonable explanation. This has led some to propose that the answer may not lie within the galaxies themselves, but on a much larger scale. Because when we zoom out even further and examine the overall structure of the cosmos, what we find is even more unbelievable than these early galaxies. According to the cosmological principle, a fundamental tenet of cosmology, the universe on a large enough scale should be homogeneous. No matter which galaxy you stand in, the macroscopic universe should look roughly the same. This principle tells us that the universe has no center and is the same everywhere. Based on this, theoretical calculations predict that large-scale structures shouldn't exceed about 1 billion light-years in size. Any larger would violate this uniformity. In other words, galaxies should be distributed like bubbles on water, some clustered, some in voids, but smooth overall, without massive, jarring structures. The problem is, that's just a theory. And even the most perfect theory must be tested by observation. And when scientists began to actually map the universe, their discoveries challenged this so-called limit time and time again. Just when it seemed theory had drawn the final boundaries for the cosmos, a 2024 observation completely tore them apart. Scientists discovered a massive ring-like structure which they named the Big Ring. Why is it so shocking? Because its diameter is a staggering 1.3 billion light-years, with a circumference of nearly 4 billion light-years. To put that in perspective, our own Laniakea supercluster is only about 500 million light-years across. The Big Ring is dozens of times larger than our own cosmic home. Even more incredible, it's not only huge, but remarkably complete, appearing from afar as a giant circle drawn on the sky. Upon closer analysis, scientists found it isn't a perfect ring, but more of a twisted spiral, as if someone had drawn a giant corkscrew in the cosmos. This raises the question. According to theory, a behemoth like this shouldn't exist. Yet there it is. If the Big Ring were a lone exception, we might call it a coincidence. But the universe keeps throwing bigger problems at us. Near the Big Ring, scientists also discovered another monstrous structure called the Giant Arc. It's so named because it stretches across the universe like a massive archway, with a span of 3.3 billion light-years. That's more than double the size of the Big Ring, and it utterly shatters the concept of a theoretical limit. And it doesn't stop there. Previous observations found the 1.4 billion light-year Sloan Great Wall, the 1.3 billion light-year South Pole Wall, and massive groups of quasars, strung like giant pearls in the cosmic deep. The question is no longer whether there are exceptions, but why there are so many. 1 could be an accident. 2 is a stretch. But as more and more of these colossal structures emerge, our theories begin to look shaky. It makes you wonder, could the principle of cosmic uniformity, which we've held for so long, be wrong from the start? These giant structures shouldn't be possible, because in our standard model, the distribution of the large-scale universe was determined by acoustic oscillations in the early universe. This should result in roughly spherical distributions, not these vast, twisted spirals and walls. Yet the Big Ring, the giant arc, the Sloan Great Wall, and the South Pole Wall are right there before our eyes. The result is that our existing theories have completely failed to explain them. This has led some to suggest we might need a new kind of physics, like cosmic strings, hypothetical cracks in space-time that may have left their mark after the Big Bang, dictating the distribution of matter. Others have made the even bolder claim that these structures could be relics of a previous universe, imprints left for us by a world that came before. The problem is, no matter which explanation you favor, there is currently no direct evidence. All scientists know is that these behemoths cannot be easily explained by our current theories. So now, we must turn our attention to an even more fundamental mystery. The answer might be hidden in the things we cannot see, but which make up most of the universe: dark energy and dark matter. Scientists originally thought the universe's expansion would be slowing down. In their view, gravity was like an invisible hand, constantly pulling all the galaxies back together. Many believed the universe would gradually decelerate, perhaps even stopping in the distant future. But a 1998 supernova observation completely overturned this idea. Scientists discovered that the universe isn't slowing down at all. It's accelerating, as if someone is stepping on the gas pedal, but we can't see the driver. So they had to give this mysterious force a name: dark energy. It emits no light and no heat, but acts like an invisible anti-gravity, pushing the universe apart faster and faster. The discovery of dark energy made humanity realize for the first time that we are not in control of the cosmos. According to measurements, it makes up nearly 68% of the total mass energy of the universe. In other words, everything we are familiar with, stars, planets, and even ourselves, along with all visible matter, accounts for less than 5% of the universe. Add in the mysterious dark matter, and that's still only another 27%. The world we live in is just the tip of the cosmic iceberg. The vast majority of existence is this invisible, untouchable force that governs everything: dark energy. It forces you to wonder, could the reality we take for granted just be a background role, while the true masters of the stage are forces we've never truly understood? We always thought dark energy was like a relentless engine, constantly pushing the universe outward. But a very recent result from 2024 has suddenly made everything uncertain. Using the dark energy spectroscopic instrument DESI, scientists made precise measurements of millions of galaxies and quasars over 3 years. Their findings suggest that the effect of dark energy seems to be gradually weakening. In other words, it's not a constant, eternal force, but more like a push that is slowly fading. Some researchers now suspect that if dark energy is indeed weakening, the universe's acceleration will one day stop. And if that happens, the entire future of the cosmos will be rewritten. If dark energy is weakening, the future of the universe will no longer be what we thought. One possibility is that it remains strong enough to continue pushing galaxies apart. In that future, the universe would become increasingly empty, stars would gradually die out, and only a silent darkness would remain. Another possibility is that dark energy's power slowly dissipates, and the expansion slows down. In that scenario, galaxies might remain in contact, but the universe would become colder and lonelier than it is today. And then there's a more extreme possibility. Dark energy fades completely, and gravity once again becomes the dominant force. The expansion would be halted, and the universe could begin to contract, ultimately heading toward a massive collapse, a big crunch. So the question becomes, are we headed toward an eternal void, or will we be pulled back to where we started? Scientists can't give an answer, but they are increasingly certain that dark energy's strange behavior is just one piece of the puzzle. Beyond it lies another, more ancient and hidden force that also dominates the universe: dark matter. When scientists first measured the rotation of galaxies, they discovered a stunning contradiction. According to Newton's laws, stars on the outer edges of a galaxy should rotate more slowly. But the results were the exact opposite. No matter how far out they were, their speeds were almost the same. This meant that the gravity from all the visible stars and gas wasn't nearly enough to hold them in such orbits. Scientists could only conclude that there must be a huge amount of invisible mass hidden within the galaxies.